There is another special case that I wanted to show you, and that was the case where we end up with no solution. So let's take a look at this system right here. They're both in the standard form. However, I've got this fraction business in equation number 2, and that's okay. You can work with the fractions. I prefer to clear the fractions. Usually I tend to make less mistakes. So if I want to get rid of this fraction of 3/2, I can simply multiply everything by 2. When I get to multiplying this term by 2, it will cancel with this denominator, leaving me with just negative 3y. So let's take a look at that. Here's my equation number 2. X minus 3/2 y equals 4. I'm going to multiply everything by 2. Where did I get 2? 2 is the denominator of this fraction, so if I multiply it by 2, those things are going to cancel, and I end up with just negative 3y. Or you could say 2 times negative 3 is negative 6 divided by 2 is negative 3. Again, you're just left with the negative 3y. But don't forget, you have to do it to everything. So then this gives me 2x minus 3y equals 8. Great, now I have two equations in standard form. Here's my first equation. 2x minus 3y is equal to 6. Here's my second equation. 2x minus 3y is equal to 8. We're not quite ready for the elimination step because if we add these equations together, neither of those variables is going to be eliminated. So why don't I go ahead and multiply the second equation, or the first, I'm just choosing the second here, by negative 1 so that it changes the signs of everything I'm looking at. Negative 1 times all these things for equation number 2. This then gives me equation number 1 is the same as it was, 2x minus 3y equals 6. Equation number 2 is negative 2x plus 3y equals negative 8. Now we're ready for the addition step. Let us then take that step. 2x minus 2x is 0. Negative 3y plus 3y is 0. We just have 0 on the left side. However, notice what we have on the right side. 6 minus 8 is negative 2. Or 6 plus negative 8, same thing. 0 most certainly does not equal negative 2. This is a false statement. A false statement of this nature implies that, in fact, there are no solutions to the system. Okay. In set notation, we could say that the solution set is empty, or something like this. Solution set is that symbol. It's not 0. This thing is the empty set. Okay. So if you had a bag with solutions in them, there wouldn't be anything in it. It's the empty set. Or simply stated, no solutions, which is probably how I would do it. But anyway, if you want to do the symbol, that's okay. So anything left about the no solution case? Oh, just what that means, kind of the general interpretation. It means that these two lines, if you were to graph them, are in fact parallel. So they never touch, meaning they never have a common point, and that's why there are no solutions to this system.